We're going to determine whether the series is convergent or divergent. We're going to use the limit comparison test. So what we're going to do is let our first series equal our original n+5 divided by cube root. I can write this, well, I'll just go ahead and write it like they have it. Cube root of n to the power of 7 plus n squared. And then I'll let my comparison series just be n divided by cube root of n to the 7th. All right, now let's reduce this. This is n divided by n to the power of 7/3, which equals n to the 3/3 minus 7/3. When you do your exponents, this is 3/3. And this is going to equal 1 divided by n to the 4/3. All right, now we're going to take our limit as n approaches infinity of a sub n divided by b sub n. So that's going to be, when you divide these two, this is really going to be n+5 divided by n to the 7th plus n squared to the 1/3 power. And then when you divide by this, it's the same as multiplying by n to the 4/3 divided by 1. So let's do that first. So we're going to get the limit as n approaches infinity of, this is going to be n to the, 7/3 when you multiply these two. Because remember, this is 3/3, so that you just add that up, plus 5n to the 4/3 divided by n to the 7th power plus n squared to the 1/3 power. Now, to make the limit easier, let's multiply the numerator and the denominator by n to the power of negative 7/3. And the reason we want to do that is to get something where we can do the limit. So let's do this parentheses there. So that's going to give you the limit as n approaches infinity of 1, multiply those two, plus 5 divided by n. And then we're going to have, for the denominator, we're going to have n to the 7th plus n squared divided by n to the 7th, and then we have to the 1/3 power here. Now what's going to happen is these are going to cancel out to 1, and then we're going to do this part here. So let's do that next. That's going to give us the limit as n approaches infinity of, our numerator is fine, and then the denominator is just going to be 1 plus 1 divided by n to the 5th power to the 1/3 power. All right, so as we take the limit, this is going to go to 0, so we're going to get 1 plus 0. The denominator, this is going to go to 0 as well, so you can get 1 plus 0 to the 1/3 power, and that equals 1, which is greater than 0. So looking at our b sub n, so all this means is that since it's greater than 0, then either both series converge or both series diverge. Our b sub n was the sum of n equals 1 to infinity of 1 divided by 4 to the, not 4, but n to the power of 4/3. That's your p series, and our p is 4/3, which is greater than 1. So that means it's convergent. And according to my limit comparison test, if this series is convergent, then so is my a sub n series. So this will be also convergent. And that's it. Thank you. Have a nice day. Bye-bye.